All right, Newton's method. This is really a cool thing, a cool way to approximate zeros. It's really kind of fun. And again, it's a pattern. So if you kind of mess up somewhere at the beginning, this could throw you off at the end. You'll need one of these bad boys to work out a Newton's method because you're going to have to do some really heavy calculating on your calculator. But it really isn't too bad. It's I think, fascinating how quickly we can approximate a zero using Newton's method. Let's just take, for example, x cubed plus 3x plus 1 equals 0. That needs to be plus 1 equals 0. Now, if we want to approximate zeros on this, we need to kind of get ballpark-ish of the 0. All right, and to do that, you may need to look at a graph, and if you can just get ballpark-ish, we don't have to be identically right up on the thing. We don't need that either. We just need to be in the ballpark. Your Newton's method will trend itself towards the closest 0. So depending on how close you are, just depends on how many times you'll have to cycle through Newton's method. It's a repeating cycle. You're going to guess an approximation for f of x equal to 0. Then you're going to use the first approximation to find the second. Then you're going to take that second approximation and find the third. Then you're going to take the third approximation to find the fourth, and then the fourth to find the fifth, and so on. And you can do this, and fairly quickly you wind up with a very close approximation. Sometimes you might have to go 3 times. Sometimes you might have to go 5 to get an approximation within several decimal places, but it's really a pretty doable thing. So here we go. We're going to need a derivative because our formula is going to be our first guess minus the function at that guess divided by the derivative at that guess. So we're going to need a lot of zeros here. So if you want to look at the graph of this, fine. If not, fine. I'm going to start off and I'm going to let x, my first x1, be equal to 0.3, negative 0.3. All right, this is a good safe number. And so what I'm going to do is I'm going to do the function at negative 0.3, and I'm going to do the derivative at negative 0.3. Now, one thing that you may want to use on your calculator that can help with this, there's a couple tricks that you can use. And one of the tricks that's easier right off the bat is to store negative 0.3 as an x value, and then you can just type in x cubed plus 3x plus 1, and you can type in 3x squared plus 3. So that's just one way to do it. When I punch this into my calculator, I do all this math, I punch it all in, and I get at the end what I do let's see here. Let's see, store negative 0.3. We'll just store that bad boy as x. And then x cubed plus 3x plus 1 is 0.073, and 3x squared plus 3 is 3.27. So to get my first approximation, I'm going to do negative 3, and then that's my first guy. So minus the function divided by the derivative. And on some of this, you may want to carry through a few decimal places just to be as accurate as possible. Let your calculator find as many decimal places as possible. So when I do that, I get my next approximation, x2, which is going to be negative 0.32234. Now I'm carrying several decimal places here because we want to determine this as close as possible. And I think, like in your book, you're going to actually carry it through to 8 decimal places. So this is a really close approximation. Then we're going to do the same thing again. So just store that number as x, and then take the same process that we just took. And once you do that, you'll get your next guy. So and I just went ahead and punched this part in right here. This part became negative point. Oh shucks, that can't be quite right. Oh darn it. I got it this time. Becomes negative 0.1, 2, 3, 1, 3, 8, 7, 9, 8. And a whole bunch more. So what we're going to do is we'll take our second 0 minus that guy, and we'll get our third one, and it's going to be even closer. So what I'm going to get is that guy minus that guy. And so my third 0 is x3. And again, you can punch all this in and store it in your calculator. It makes it easier. And then we'll do it again, and I'll just tell you on that one, when you punch it in, let's move these guys up a little bit here. So when I do the fourth guy, then I'm going to end up with negative 0.322185, 3, 5, 4, 6. Look how close that we lined up here, all the way to that point right there. So this is called Newton's method, and again, it's just a pattern. Just repeat, 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 and you'll get closer and closer and closer, and you'll eventually get to that 0.